This is lesson 11.4, and today we're going to be talking about corresponding parts of similar triangles. So let's first take a look at the two triangles that we have in front of us right here. So the first question right here is, are these two triangles similar? So I'm trying to get you to think back to what we talked about in previous lessons, and especially the shortcuts for proving triangles are similar. And since two angles in this triangle are congruent to two angles in this triangle, they're marked there, there. The shortcut that proves that they are similar is AA. So what does that mean? Right here, that means that the angles are congruent, and it also means that sides are proportional. Alright, just more review there. Alright, and so that deals with angles and sides. And so the big question that we're trying to answer in today's lesson is, are there other parts that are either proportional or congruent? And I guess I wouldn't be making the lesson if there wasn't other parts. So here we have the same two triangles. Remember, they are similar because of AA. And here we have an altitude, and here we have an altitude. And let's pretend for a moment that we calculated the ratio, and I don't know, this is 6 and this is 12. Since the triangles are similar, the ratio of the smaller triangle to the larger triangle's sides is 1 to 2. Well, as it turns out, the altitudes are also proportionally related in the same ratio as the sides are. So when two triangles are similar, not only are the sides proportional, but the altitudes are also proportional. Are there any more parts inside triangles that we could discuss today? Yes, there are. So here we have the medians, and I'll remember that the median connects the opposite vertex right here with the midpoint of the opposite side. Opposite vertex, this is the midpoint of the opposite side. Let's say we measured these two sides. Let's say this was 4 inches, this was 8 inches, so the ratio is still 1 to 2. And so the question is this median and this median, are they related in the same proportion as the sides, seeing as how the triangles are similar because of AA? And the answer to that question is yes, they are. Medians are also proportionally related to the same ratio as the sides. Alright, so we've talked about altitudes, we've talked about medians. What about angle bisectors? So here we have this angle congruent to this angle. In a separate triangle, this angle is congruent to this angle. And the answer to that question is, let's say the ratio of this one was 3 and this was 9. So this ratio would be 1 to 3. I guess I could write it like that as well. And so the question is that are the angle bisectors related in that same way, seeing as how these two triangles are similar by AA? And the answer to that question is, as you probably predicted, yes, they are. So angle bisectors, in other words, this line right here, is proportionally related to this line as long as the two triangles are similar. Alright, so those are 3 more corresponding parts to similar triangles that are also proportionally related. Alright, that's the first big idea for what we're talking about today. The second big idea, before we talk about the next big idea, how about a little humor, huh? How about, what do you call a cow with a twitch? Give you a couple seconds. Beef jerky. Alright, I know you're laughing hysterically. Now let's talk about the second big idea for the day. Alright, here we have a construction, which I know you all fondly recall, and hopefully you get that this is a construction of an angle bisector. Alright? So that's the first thing. The second thing is, let's compare the ratio of this side of this side of the triangle to this side. That ratio is 6 to 12, which means it's a ratio of 1 to 2. 1 to 2. Now, let's just do a little inductive experiment here. If I take this side length right here, how many of those side lengths does it take to find? Look at that. It's exactly 2. In other words, what I'm trying to point out here is that this ratio of this right here is 1 to 2, which is exactly the same ratio of this leg or side to this side of the triangle. Alright? So the idea here is that the angle bisector divides the opposite side, which is here, into a ratio, into two parts that are in the same ratio as this side and this side. The two sides that are in between, or that have the angle that's being bisected in between it. Alright, so this lesson has two really big ideas then. The first big idea is that inside of two similar triangles, like I have here and here, we have an altitude, we could have a median, and we could have an angle bisector. We're going to pretend that this line right here and here represents all three of those. The idea is, as long as these two triangles are similar, all of those are also similar. And by those I mean altitude, median, and angle bisectors. The second part was, inside a triangle, if you have an angle bisector, it divides this opposite side into the same ratio as the two sides that make up the angle that's being bisected. So here the ratio is 8 to 16, which means the ratio of this segment to this segment is the same, 8 to 16, which we simplified in 1/2. Alright, those are the big ideas from 11.4.